Alright, so today we're going to be going over how to show adding and subtracting integers with chips, which goes along with your notes. The very first thing that we're going to do is just a quick review on some of our integers. So it says to write the integer to represent each quantity. Number one says a profit of $250. It's good to make a profit. You are adding money to your bank account, so that's going to be a positive 250. Number two says 18 degrees below zero. On your thermometer, when the temperature goes below zero, it is a negative number. So that below word is our key word that tells us it's a negative 18. Remember, integers need to be whole numbers, positive or negative, and also including zero. Number three says a loss of 8 yards. A loss is our key word that tells us it is a negative 8. Number four, it says an elevation of 3,400 feet. Elevation is kind of a tricky one. Sometimes it can be positive or negative, but they will tell you below sea level if it's negative. So since it does not say that, this is a positive 3,400. Our next two examples have us ordering from least to greatest. So if I'm looking here, I'm looking for the smallest integer that I see. Negative 20 is going to be the lowest integer there. Moving to our higher integers, we have negative 15, 17, and then 19 is our highest one listed. On number 6, this is a little bit tricky because they are all negatives. Remember, the bigger the number is in the negative, the smaller that actual integer is worth. So our first one is negative 83. Negative 77, negative 74, and negative 62. All right, we are ready to move on to our next slide. So now we're learning how to add and subtract with those negatives. So we use chips for that. Our chips have two sides usually. For this presentation, we're going to be using yellow for positive and red for negative. You can see that I have my signs on my chips already. Our first example, we're just going to start reading it and see what happens. So it says to begin with 4 positive counters. And then I'm going to go ahead, got to switch to my chips. I'm going to go ahead and use those negative counters. So I'm going to put 4 positives in front of me. So 4 yellow counters. Then it says that I'm going to go through and add 4 negative counters. So those negatives are going to be red. I'm going to go ahead and bring them over as well. So before we get too farther in our picture, we're going to go ahead and write out our number sentence. So those 4 positive, the integer I'm going to use is a positive 4. So again, I used a positive 4 for that first integer, and then because I'm adding, I'm going to put a plus. And then I have 4 negatives, so I'm going to use a negative 4. And sometimes it can get a little bit confusing with the plus and then the negative, so we can use parentheses to help group that integer together. So you'll see that usually with the second number. Sometimes they'll put it on the first, but you need to be able to see both. All right, so these 2 boxes in our picture column, it's kind of like a party. At the beginning of our party, everyone's arrived, we have those positive counters, we have those negative counters that we have up in our box at the top of the screen. So I'm going to go ahead and draw those on the left-hand side of our pictures. So you can see I've put in 4 positives, 4 yellow dots, and now I'm going to go ahead and put in 4 red dots. So I'm drawing exactly what we've already done. Now the thing about these parties is that you don't want to leave until your best friend leaves, and if you leave, you're going to bring your best friend with you. So our best friends are going to be a positive and a negative together. So to show them leaving my party, I'm going to circle them. You can see I'm circling my 4 groups of best friends. And that means that they can leave the party together. So I'm going to go ahead and show you that on the top box. I'm going to take out a positive and a negative. Those are my best friends. Another positive, another negative, another positive, another negative, another positive, and another negative. So my 4 best friend groups are actually what we call 0 pairs. That means that a positive and a negative get added together to be a 0 pair. So once all of my 0 pairs have left my party, whoever's left is going to be left in that box. Now this is a special case. I don't have any chips left over, so I'm going to put that my final sum is 0. I do not have any chips left in my party, so that means my solution is 0. And this goes back to our properties that we learned about. A positive 4 and a negative 4 are inverse of each other. They are opposites, so that's the inverse property of addition. My final answer is 0. Let's try another one. So in this one, I've got 3 positive counters, and then I'm going to add 6 positive counters. So I'm using those yellows to show. So I'm going to pull over 3 positives to start, and then I'm going to bring over 6 more positives. I'm inviting more people to this party. Let's go ahead and write out that number sentence. 3 positive, I'm just going to use a positive 3. I'm going to add, plus sign, 6 positive, positive 6. Now I'm going to go ahead and write it in my notes, what I've just done with my chips. So I'm going to put in my 3 from the very beginning, and then my 6 that got invited as well. And now I'm looking for those best friend groups that can leave the party together. Remember, a best friend group is a 0 pair, a positive, and a negative together. I actually don't have any negatives at this party, so no one can leave. So at the end of my party, that second box, I've still got those same 3 from the very beginning, and then the 6 positives as well. And those are going to add up to be 9 positive, which we already know. We know that 3 plus 6 is a positive 9. So now we've learned how to do it in chips, and if you take a look above your chart, it says positive plus a positive, and it actually turns out that whenever you have a positive number and you add a positive, you are going to get a positive answer. Alright, so that one was one we've already known. Let's try some with negatives now. So I'm moving on to our next example. In this one, I'm beginning with 2 negative counters, and then I'm going to add 4 negative counters. So I'm going to show that. I'm going to put 2 negatives in front of me, and then I'm going to put another 4 negatives in front of me. All right, let's write out our number sentence. So I've got 2 negatives. I'm going to use a negative 2. I am adding 4 negatives. And remember, I can use those parentheses to make it a little bit more clear to read. On my left-hand picture, I'm going to draw what I've already done with my chips. I'm going to put my 2 negatives, and then the 4 that joined as well. And now I'm looking for those best friend groups, those 0 pairs that can leave the dance together, the party. I don't have any positives, so no one can leave. So that means at the end of the party, I still have the 2 from the beginning and the 4 negatives that came as well. And that actually gives me a grand total of 6 chips, and they are red, so it needs to be a negative 6 for my final solution. So negative 2 plus negative 4 ends up equaling negative 6. A negative plus a negative is going to make a negative. All right, let's try one that's a little bit different. I've got 2 examples here. The first one says begin with 3 positive counters, and then I'm going to be adding 6 negative counters. So I'm going to put over my 3 positives. I'm going to put over 6 negatives. I'm adding them all to my party. And what I'm going to do now is I'm going to write out my number sentence. So I've got 3 positives, that's a positive 3, and then I'm adding 6 negatives, put that in parentheses to make it a little bit more clear. And now I'm going to draw the beginning of my party, everything that I've already got in my box, up at the top, 3 positives and 6 negatives. All right, now I'm looking for those best friend groups that can leave when the party's coming to a close. So I've got a positive and a negative grouped together. I'm going to circle them, and then I'm going to take them off of the dance floor, out of the party. So I find that there's actually 3 pairs, 3 0 pairs that I'm going to get rid of, move them out of the box. And now I'm left with 3 red chips at the end of my party. So remember, that right box is the final answer. So I've got 3 red, that's a negative 3 for my solution or my sum. All right, we are going to try that last one there. This is our last addition problem example. We are going to have 4 negative counters, and then we're going to add 5 positive counters. So I'm going to take 4 reds, put them on my party, on that dance floor. And then I'm going to also add 5 positive, 5 yellows. There's my 5th. And now I'm going to go ahead and write that number sentence. So I had 4 red, so that's going to be a -4. And I'm going to add 5 positive, a +5. I'm going to draw my dance floor, that party. 4 reds. And then 5 yellow circles. And now I'm looking for those best friend groups that can leave. So I'm going to circle them on my drawing and move them out of my dance floor up on top. So take out, remember they leave with their best friend, so a red and a yellow can leave together. And once all my best friends who can possibly leave have left, I have 1 positive left at the end of the party. My final solution is going to be a +1. All right, that's the end of our addition examples. Let's see what happens when there's subtraction. So the big difference that I see as I'm looking at this chart is that the pictures has 3 boxes. So we're going to figure out how we're going to fill those in together. My first example starts out just the same as our adding ones did. I'm going to look for those keywords. I've got 5 positives, and then it says that I am taking away 3 positives. So my number sentence, let's start with that. I've got 5, a +5, and then take away, I'm going to use a subtraction sign, and then 3 positive. Now let's get those chips out. I'm going to start out with 5 positive chips. Those are yellow chips. Now the thing about subtraction is that some of those chips are going to get kicked out of my party. They are going to leave so fast that it doesn't even matter if they have their best friend with them. So when I'm drawing my pictures, I kind of have 3 boxes. The first box is going to be the beginning of my party. So I'm going to write my 5 chips that are here at the beginning of my party. Now in the middle, I'm going to have those people leave. They're leaving in the middle of the party without their best friend. So I'm going to draw the people who were there, my 5 positives. And then it says that 3 positives are going to get taken away. So I'm actually going to circle those 3 that are leaving and draw an arrow out of the box. They are leaving the party. They don't even care if they have their best friend. So I'm going to move them out of my box up here. And it looks like I have 2 positives left over at the end of the party. I don't have any best friend groups that are leaving, so I'm done at this point, and my final answer is a +2. And we know that 5 minus 3 is a +2. Let's try another one. Now I'm going to begin with 6 negative counters, and then I'm taking away 3 negative counters. So I'm going to write out my number sentence, a -6 minus a -3. And again, I'm going to use that parenthesis on my second number to help me keep it separate. Let's clear my board. I'm starting out with 6 negatives at this point. So I'm getting 6 red chips out on my dance floor at my party. And then I'm going to draw what's happening at the beginning of my dance. So I've got 1, 2, 3, 4, 5, 6 negatives. Now, just like the last one, I've got some people who are leaving in the middle of the party. They don't even care if they have a best friend. That's what happens with subtraction. So I'm going to draw the people who were here, 6 negatives. And then it looks like I am kicking out 3 negatives are leaving in the middle. So I'm going to circle those 3 and draw an arrow that goes out of the box. Going to move them out on my board up here, and then it looks like I've got 3 negative chips left over. So that means that my final answer is going to be, my difference is going to be a -3. All right, I want to draw attention to the top of our chart. It says that there are enough chips here. So in these 2 examples, I had enough chips that I could kick out. They could leave in the middle of the party. Our next 2 are a little bit tricky, so we're going to go slow and take it one step at a time. So in these examples, we're going to find out that there's not enough chips, and that's going to kind of change what happens in the middle of our party. So our first one here, it says begin with 4 positive counters, and then we are taking away 3 negative. So I'm going to write my numbers. I'm going to write my number sentence. That's a +4 minus a -3. Again, I'm going to use those parentheses to keep it clear. Let's draw the beginning of our party. We start out with those 4 positives. So I've got those 4 positives, and it looks like I'm trying to kick out 3 negatives. However, I don't have any negatives. I've only drawn yellow circles, so I don't have any negative chips to kick out of my party. In order to kick them out, they have to come to the party first. So in the middle of my party, I'm going to realize I don't have enough, and I'm going to put the 4 that I've already got, 4 positive. And then I'm also going to invite the 3 negative that I know I'm going to kick out at the end. But the thing is, when they show up late, they don't come alone. They're going to bring their best friends with them. And the reason that we can do that is, remember, our positive and negative makes a 0 pair. So when I added those 3 negatives and they brought their best friends, it was really adding 0. And it looks like I actually only need to bring 3 0 pairs, so I'm going to get rid of 1 extra that I pulled over by accident. All right. So now I've invited everyone who can come to the party. I know I'm going to kick out those 3 negatives. So again, to show that I'm kicking them out, I'm going to circle the negatives that are leaving early and drawing an arrow out of the box, out of the party. And remember, in subtraction, they don't even care if they have their best friend. They are leaving without them. So at the end of the party, I have the 4 positives that I started with. And then I also have the 3 positive best friends that came along with those negatives, but they got left behind. So my final difference here, 4 minus a negative 3, is actually going to be a positive 7. I've got 7 yellow chips left on my dance floor. All right, I know that these are tricky, so we're going to try another one to make sure that we've got it. In this example, I'm beginning with 2 negative counters, and then I'm going to take away 4 positive. So I'm going to write out my number sentence, 2 negative, negative 2, minus a positive 4. So remember, the beginning box, I'm going to show what's happening at the beginning of my party. I've got a negative 2. Let me put it up at the top corner as well with my chips. A negative 2. Now I'm trying to kick out 4 positives, but I don't have any yellow chips, so I cannot kick them out yet. So what I'm going to do is draw my 2 negatives that I already had, and now I'm going to invite who still needs to come to the party because I know that I'm going to kick them out. So I've got the 4 positives that I'm going to invite, and then they don't show up alone. They are going to bring their best friends with them. Remember, those make 0 pairs. I'm going to show you with the chips. So I invited those 4 positives. And then they brought their 4 best friends. And now I'm going to show them getting kicked out. So those 4 positives got so mad they left without their best friends, left them behind. I'm going to draw that arrow to show that they're leaving. And now I'm going to go ahead and bring them out of my dance floor up top. And it looks like I have the 2 from the beginning, plus the 4 best friends that got brought along and left behind. So that gives us a negative 6 as my final difference. So let's fill in this blank. So when there's not enough chips, we have to invite or add 0 pairs so that then I can kick out those chips. So if I don't have what I need, I can add more 0 pairs to help me out. So that concludes our lesson on subtracting and adding with integers and chips. We will go ahead and learn about multiplying and dividing in our next video. Nice job. See.